Hey students, I'm back. I had to do a quick impromptu meeting with some of your ex-teachers from last year, Mr. Citro and Mrs. Jones. So collaboration is key here. So try to hopefully you guys use that too in your own tasks here. So getting back to solving and graphing inequalities with integers, which is exciting stuff. We say n divided by 3 is greater than -4. Now, I see that n is a positive, or I'm sorry, not n, I'm sorry, 3. The denominator 3 is something that's positive. So I am not going to flip the inequality symbol like I did last time, and we'll check it to make sure. So again, I don't want to figure out what 1/3 of n is. I want to figure out what 1 whole n is. So instead of dividing by 3, I'm going to multiply both sides by 3, recalling that I can change any whole number into a fraction simply by putting it over 1. So that leaves me with n on this side. I'm going to multiply this side also by 3. So now n is supposedly greater than -12. Now if I were to graph that, open circle because -12 is not included in the solution set. Now let's see here, n is greater than -12. That would be -13. That's actually less, so I graph to the right. Now let's check to make sure this works. So again, any number greater than -12 will make this solution set work. So let's just try 3. Let's try 3 and I'll substitute it in. 3 divided by 3 is 1. Is 1 greater than -4? Yes, it is. If I had flipped that inequality sign on accident, thinking that this is a negative, again, it would not work, because then I'd say n is less than -12, and I put a number that's less than -12. Let's just try -5. If I put in -5, or I'm sorry, -15, my fault. -15 divided by 3 is -5. Is -5 greater than -4? No, it's not. So this is vital, boys and girls, that you check when you're doing these inequalities, to check to make sure that it makes the inequality true. Because like I said, if this were anything in this chapter that really threw off kids from last year's pre-algebra class, it's when to not and when to flip that inequality symbol. All right, and checking it really is a great way to just reassure yourself that you have the inequality sign in the right direction. All right, let's try another one. Ooh, x minus -10 is less than -2. You know, I'm going to rewrite this. I don't like the way it's written. If I knew what x was, I would immediately change it, saying, hey, x, because when we subtract integers, we're actually adding the opposite of that second integer. So x plus the opposite of -10 is +10 is less than -2. So I'm going to write it like that. Now I can approach this in a much more efficient manner. So I've just simply changed this, and I didn't really change it, I just kind of made it in more friendly terms. So now I know I want to get rid of this 10, so I'm going to subtract 10 from both sides. This cancels out, so I'm left with x. Now this side here says -2 minus 10. When I am subtracting integers, I add the opposite of that second integer. Well, the opposite of 10 is -10. So I have -2 plus the opposite of 10 is -10. Okay, signs are the same, a negative and a negative. I know my answer will be negative, so that's 2 plus 10. I owe you $2. Now you know they're $10. Now I owe you $12. So owing is a negative. So now I go back to the original equality. It says x must be less than -12. So there's my solution after all that mumbo jumbo. X, or -12, is not included in the solution set, so it's an open circle. And it says less than, so I graph to the left. Let's just pick a value that's part of the solution. Let's just say -20. So if I plug this in, substitute it in, let's use proper terminology here, Mr. Giomini. I'm going to say x is equal to 10, or -20. So if I said -20 plus 10 is going to be less than -2. Notice I used this inequality here rather than this one. Okay, -10 plus, or -20 plus 10, signs are opposite, so instead of adding I subtract. 20 minus 10 is 10. -20 has a larger absolute value. It is further away from 0. It is negative, so this answer here will be negative. Is -10 less than -2? It sure is. So this would work. So my inequality is true. All right, let's take a look here at taking and translating word phrases into inequalities. A number divided by -9 is less than or equal to 8. Notice it just says translate, doesn't say then solve. So a number, don't know it, we'll call it n, divided by negative 9 is less than or equal to, so I'll underline 8. Okay? A number less than 17 is greater than or equal to 25. A number less than 17. A number less than 17. How would I write that? Is greater than or equal to, I can do that side, 25. Some number less than 17. How do I write that? I'm going to come back to that. Let's talk about that. A number multiplied by negative 19 is greater than 11. A number, we don't know it, multiplied by negative 19. Now, here's the problem. Saw this on the Unit 1, or Chapter 1, sorry, test. A number multiplied by negative 19. Remember, there's multiplication here with an unknown, so the negative 19 is our coefficient. So we put that negative 19 first. So, negative 19 multiplied by a number is greater than 11. Okay, a number increased by negative 18 is less than 35. A number, we don't know the number, but it's increased by negative 18. So that means I start with a number and I add to it negative 18. I'm going to put this in parentheses to kind of show the separation between the plus sign and the negative, is less than 35. Okay, let's go back to that one I was questioning. A number less than 17. How would I write that? A number less 17. A number less 17 is greater than or equal to 5. A number less 17. A number less 17 is greater than. I'm thinking it's a number that's 17 then smaller is greater than or equal to 25. If I were to solve this, I would add 17 to both sides. That would give me, what is that? 17 plus, that gives me 43. 43 minus 17 is 25. Now that says n must be greater or equal to 25. So then I could plug it in, any numbers. It would make it true. Okay, there we go. Hope this helps you. Have a great one.